So here we are again. Next step is the disassembly. The curing has been completed and we are going to take this curing tool apart now and to disassemble not to disassemble the stack here, of course, but to remove the stack from the curing tool and to insert it into the TIMA for testing. So I'm gonna zoom in a little bit to give a more proper detailed view, so it appears that our layer has made good progress. It turned a little bit brown on the outside, maybe just from the heat, but I already viewed a previous sample, and on the inside, draw sharpness here, on the inside appears to be pretty well. So these small holes, they actually come from breaking the sample. So this has nothing to do with bad quality or something. It's just from breaking the sample. Okay, now we are going to take this sample apart. And this begins with loosening these 4 screws on one side. So just loosening them, and then we are going to unscrew these large screws. I still hold this whole piece together so that doesn't happen anything I don't want, because what we have to be very careful of is that we do not apply torsion or any other tension apart from, or any other strain apart from pressure, from direct pressure. Direct pressure will probably not do any harm to the layer, but any way of pulling, of turning, and of opening the gap, like shearing, will tear the interface most likely apart. So this is the side I loosened now, and I'm going to hold this part and slightly remove this part here, so I do not do any strain on the sample I do not want to have. So now we have just the bottom side remaining, and I'm going to remove the bottom side. So now for the last screw, I hold it a little bit on the bottom side so it doesn't fall out and damage the layer, and now it's already loose. So I carefully take it out, and here we go. This is our nice sample, our cured sample. What I will try once I have a good measurement point is to remove the outer material, the overlapping material. From our experience, this does not affect the measurement result to an extent which is has to be regarded, has to be considered. But because the heat spreading in this small layer thickness, here we have about 700 microns, is very, very little compared to the overall cross-sectional area of the sample. So that is why I would rather keep this layer intact and not risk doing any harm and any breaking on the outside, which might cause cracks inside the layer I want to measure. So this is the stack I'm going to put into the testing machine, and I will return with images from the testing. Welcome at the testing range here at Nanotest. So we have our cured sample available now, and this is the TIMA software and the folder where we store the results files in. This is the TIMA software, which is used to control the system, to do the measurement, and to keep an eye on all the values if the measurement is valid. So we are going to apply this sample, this prepared sample now, inside the machine, and for this purpose I'm going to zoom in on the machine itself. So this is the spot we are going to put the sample in, and we begin with putting a small copper disc on the bottom side. Well, there's actually no defined bottom side here, but we need this as the contacting phase for the bottom side, for the cold side, and the other end is going to be screwed into the heater on the top side. So when screwing, it is very important again to take care that the sample is not being torn somehow or being twisted. So I always just turn on the one end which I want to fix. So, and now we are ready to go. I am taking control of the software now and control the motor. So what I'm first of all going to do is to adjust the force to 0, because we have a differential force measurement. Need to set the point of 0, which is now, because there's no pressure and no tension on our sample. So and now I'm going to move down. First of all, a little quicker, as far as we can call this quick. But this is a stepper motor and takes its time to move its distance. So, and now slightly before we actually get in touch with the cold plate on the bottom side, we take a close look whether both faces are more or less parallel. That the bottom side isn't perfectly parallel is not a bad thing. It's no issue, but we do not want to have large tilt. So we are taking care of that by visual inspection. Of course, I did preliminary tests, and in this case it is nearly perfectly parallel. So I put a decent amount of thermal grease below that copper disc in order to ensure heat spreading over the full surface. And now I am moving down a little more slowly, and I'm going to zoom out now once again and show the software. This is now automated zoom, so please excuse that. Okay, I think the numbers in the software are quite sharp. This is the value we measure about the force. So this is around 0 now. If we show the force, there's 0 Newton approximately, and so what our target is 50 kilopascal, which is approximately 7 Newton of pressure, and we are carefully moving downwards, and now switch to the controlled mode, which is up here. We can set up a control parameter, which will be the pressure in our case. We could control the bond line thickness, of course, we could control the force, but we may also control the pressure. So we click on activate, and now we can observe the pressure slightly and slowly going upwards and increasing.